Industrial Revolution wasn't a grand plan. It started with a lot of people, just tinkerers. And there were some scientists as well, but a lot of the early stuff was just people tinkering. So I thought it was appropriate to begin this lesson in my garage where I do some of my tinkering. And so today we're going to show you some of the key inventions of the Industrial Revolution and try to explain what went on. If you're a fan of the Sleeping Beauty movies, you have probably seen one of these. This is, of course, a spinning wheel. Now, this was, before the Industrial Revolution, this was a really important piece of equipment because this is how you made thread, which of course will matter. Now, what I have here is, this is the beginnings of having threaded the spinning wheel. So you start with basically yarn like this, and in effect, as we've discussed, it's about turning your wheel. Now, this model of the spinning wheel has a foot pedal. You can't really see on the video, but as you turn it, it turns this spindle, which then in effect spins your thread. And so I'm going to do a little bit here. I've never quite been able to get this spinning wheel working perfectly, but you know, as we say, you get what you get and you don't get upset. So you hold the thread, and as it spins and as I'm pushing my pedal. Now, of course, later machines, as we'll see, would use water to turn this. So the more you spin, the longer your thread gets. And in effect, you would then put this onto spindles and bobbins, which we will go take a look at next. Ultimately, that's what the Industrial Revolution was about, was using machines to do things that people did for a long time. And really, when you think about it, it comes down to something as simple as this. Like, how are you going to turn a wheel to generate power? So behind me, this is a water wheel I made a couple years ago for lessons like this. And this was one of the earliest ways they had to create power. And basically, this water wheel has a pump which moves the water up to the top here, you can see, and then it goes down. That's called an overshot wheel. But in reality, the way these worked was you would find a river or a stream, or create some type of man-made waterway, and you would put your water wheel there. And then through a series of gearings, which we'll take a look at some pictures of, you would then power all the machinery in your mill. And they did that for early textiles. Now, obviously, the limitation of this is you need a supply of water, which for us is we recirculate it through the pump and it comes from a hose. But in reality, of course, that would be the river. But if your river runs dry, then you're stuck. You're also limited by geography as to where you can put these mills. But eventually they would find other methods to power that wheel, such as steam. Now we can use nuclear power, but it all ultimately comes down to powering your wheel. And this wheel isn't actually connected to anything, but it could be. Now that you've seen what a working water wheel looks like, I wanted to show you a model of what one would look like that is actually connected to do something. So this is a model I picked up in China at a gift shop, and it just shows the early, kind of what an early mill would do. So what you can see here is we have a wheel, okay, and then however you're going to generate the water or the power to turn that wheel. So in this case, I have a crank on the other side. So as I turn it, you can see the handles, those little hammers that are doing the pounding. And you could use whatever it is, you know, whatever you wanted to connect to this wheel. Here you can see the main shaft, but you could do just about anything else you wanted to. And again, it's how about you turn your wheel. So another earlier method of power, you can see behind me here, this is a windmill. I got it a kit at the local hardware store. But wind, this is making a bit of a comeback today. You can use wind to turn your wheel and power things. And this, again, this is like a newer style windmill, but you saw these in the Netherlands, etc. But again, ultimately, you might have challenges with it being reliable and what you could do. So if you can have a more reliable way to turn that wheel, that would be even better. Now that you've seen how a spinning wheel works, the next big invention was, of course, the spinning jenny, where in effect you automated spinning wheels. Here's a picture of what one looks like. It's just a big, water frame. There's water frame and then the spinning jenny, but they both in effect spun thread. Now, once you have all that thread, well, what do you need to do? Well, you would start with a loom, which is hand weaving, where you take a shuttle and you push it back and forth and then pull your hands down. And in effect, you can make, you weave thread. Here's a picture of me at a workshop in Lowell, Massachusetts, which is where they had some of the early textile mills. And you can see here where I'm working at the loom, and I was not very good at this. So in about 30 minutes, I was able to make this lovely bookmark. Not all that good. But what happens is once you have all that thread, you figure out a way to automate it. So here's a couple of accessories. This is a bobbin from one of the water frames or the spinning jenny, and in effect you would do what the spinning wheel did, and it looks similar to my bobbin on the spinning wheel, but you would have like 80 to 120 of these and gather your thread. Then once you have your thread gathered, you might transfer it onto something smaller like this. And then this is a power shuttle for a power loom. And what would happen is you would weave the thread through this hole here, and the girls on the loom would have to suck it through. And then this is going to go back and forth really, really fast. Then when it is played out, when its thread is all gone, your job would be to load in a new cartridge, like so. Now you got to be careful because this thing is quite sharp and heavy and dangerous. But what took me half an hour on the regular loom, a power loom did this length of fabric in about 5 minutes. And you can see that here. So that is the advantages of automation, and it is going to work much, much faster than anything else that we have. So this is one of the earliest and probably one of the most important Industrial Revolution machines. This is a replica of the James Watt steam engine. Now, Watt was Scottish, and he invented this to actually help pump water out of coal mines. Now, this one is sort of a jury-rigged model. So what you can see on the bottom is, if the water doesn't leak, there's a hose, okay, going from the bottom of this trough into the cylinder. So in the actual coal mine, what would happen is you would use steam to power this, and then inside the cylinder, it would create a vacuum. And then that vacuum would suck water up into the cylinder. Now, in this case, we are just recycling. So the water goes into the hose and then back into the tank. But in reality, you would put the hose off to the side and you could drain it into something like a cup. So let's like so. Now I'm using my hand, of course, to power this, but in reality, this would be done by a steam engine. And so you can see, if you look at the hose, the water going into that. And it's just up and down. Now our next invention is the real deal. This is an actual replica steam engine that you can see here, and I will move my table closer in a little bit. But so this is a replica steam engine. This one actually works. Now, the principle of the steam engine is actually fairly simple. You have, this is an extra boiler that I had because it broke. But you fill this tank with water, and then the water is going to boil. And then as the water boils, the steam will go up into this pipe. Okay, the pipe, if I lower this valve, I am like kinking a hose, and the steam builds up the pressure. When I'm ready, I release the steam, and this will fire. And then this wheel here, this flywheel, will spin, and it's just a matter of what I connect to my wheel. Okay, so I'm now going to load the fuel into the steam engine. Now, I use camping fuel for this, these little pellets, because they're pretty efficient. But in reality, of course, this would be done with wood or coal. They started with wood, but then coal was a much more efficient. Coal was much more efficient. Pardon while I get some scissors to cut. So the way this particular thing works is we load up our fuel into our, this would be like the people shoveling coal into a train. Okay, and now we are going to light. And just like in a real engine, we are going to light our fuel on fire. And of course, coal turned out to be much more efficient than wood because it burns longer. And England happened to have a ready supply of it. And they had pretty much used up most of their wood. And they were also competing with the Navy for the fuel. So now we take our fuel, and you can see we are putting it under the boiler. Now it's going to take a few minutes, but we are going to let the water boil. And while that is getting to boil, let's show you a few of the other permutations of this invention. So as you can see with the steam engine, it is, again, just pretty simple. It's a tank. This smokestack is fake, of course, but that would be belching out all kinds of pollutants. But if you look at this early model, this is one of the earliest trains called the Penny Darren. And if you look at this model, it doesn't look that much different than the steam engine. It basically is a tank of water on a steam engine connected to some gears, and you just attach some wheels. So when this thing goes, now this originally had a spring, but it doesn't work that well anymore. But basically, if I turn the wheel, and this would be steam doing this, you can see the wheels turn. And that is, it broke a couple years ago, but, and you can see it's just a matter of how am I turning that wheel. And these early trains could go at the earth-shaking speed of 20 miles an hour. And they actually had scientists going, what will happen to the human body? It's not meant to go that fast. So this is, of course, the coal car you would need to fuel it. Now, if you take a steam engine, and what if you attached it to a boat? So this is a model, this has seen better days, but this is a model of a steamboat. And so literally, you have the wheel, the paddle with the steam engines right here, and then the wheel turns, and you can generate anything. And this revolutionized transport because people could go upstream for the first time. And eventually, once they get these things going transatlantic. This is a replica of one from the American South, hauling cotton up and down some of the rivers. But it's the same, again, turning that wheel. We are back, and here you can see our engine. The water is at a boil. So we are ready to make it fly. And let's take a look. So I'm going to release the throttle. And then, and as you can see, this thing can generate quite a bit of momentum. And then as long as I have enough pressure, so when the pressure starts to wane, I can lower my throttle and let the pressure build back up. Now later steam engines would have 2 boilers, so you could avoid this problem. And if I turn it up again, give it a little kickstart, and there we go. Blowing some of the steam away. And obviously, the challenge is, or what you would do is you would connect anything you would like to this. And as long as you connect something, it could be a train or a steamboat. So let's generate this. And we'll let it crank again. You can see the steam level is going. Our fire still burning. Now, one of the risks, of course, with the steam engine is that if you build up too much pressure in the boiler, it could explode. So as an emergency release, although my handle has gotten short, but you can release this as an emergency release. And we've probably all heard this. And that would be your way to release some steam pressure. So we'll lower that down because we don't really need to worry about that. And let's take one last look at the wheel. Okay, so now I'm just going to let the steam pressure release and play out. So here you can see some video I took a few years ago of the turbines at Hoover Dam. Now these turbines are very large, quite enormous actually. And a turbine is just the modern way of turning a wheel. And we just use it to generate electricity. So the way a turbine works is you spin a magnet inside copper wire and it will generate electricity. And the way they choose to spin the wheel in a hydroelectric dam like Hoover Dam is they release water, and in effect that spins the turbine. So if you look closely, you can see the turbine spinning. So in reality, we haven't really changed the principles much, just what we use with our spinning wheel. And electricity obviously has advantages because you can transmit it and then convert it to power anything. Last thing I want to show you, this is one of my favorite things, although it is definitely getting the worse for wear. This was Thomas Edison. This was one of his favorite, actually his favorite invention. And if you look real closely, it's hard to see on here, but there are raised bumps on this piece of tin foil, as frayed as it is. And this is actually how they recorded the early phonographs. Original records were basically cylinders. So the original ones were tin foil like this. But eventually someone figured out wax cylinders would be better. And then someone said, oh, if we flatten out the wax cylinder, we can get a disc. That would be a record. But this is the first recorded music. Now, what was the first thing Thomas Edison ever recorded? It was actually Mary Had a Little Lamb. So when he was all set up to demonstrate the phonograph, he had a whole speech prepared. But when he started in front of the crowd, he panicked, got stage fright, and just recited the first thing that popped into his head, which was Mary Had a Little Lamb. And that is why that is the first recorded sound ever. But this was really revolutionary because there had been nothing like this ever.